Welcome to the IM2 video lecture on Congruency Transformation PowerPoint lecture. The learning target is for you to understand how geometric shapes are congruent. The two success criteria that you should be able to do by the end of today's video are identify what a congruency transformation is and use congruency transformation to find congruent geometric shapes. Let's look at the discovery. This question was on the previous PowerPoint lecture. We went through this problem and saw that you can make angle PRS into angle WRQ by either reflecting it on point R or rotating it 180 degrees on point R. Therefore, if angle PRS is 40 degrees, then we know that angle WRQ is also 40 degrees because you can create that with a rigid transformation. So you can say angle WRQ is equal to angle PRS by reflection on point R or rotation on point R by 180 degrees. This is the idea of what a congruency transformation is, having two geometric shapes that are identical. We are going to now look at the core concept. The core concept of congruency transformation. Congruency transformation is the process of moving the location of the object without changing its shape or size. A rotation is one of them, where you turn. A reflection is where you flip, and a translation is where you slide. These are your three types of congruency transformation. Please note that the length and angles are the same in both figures. For example, if we see that the angle of, let's say, this is 30 degrees. When it was rotated, this was also 30 degrees. Likewise, we can say if this side was 3 inches, when it reflects, this was also 3 inches. Notice that the angle does not change during the transformation. The length does not change in the transformation. The only thing changes is its location. Also note that you're going to see these two words interchangeably. Congruency transformation and rigid transformation are the same word. These two words are just academic words, but all it means is that you are changing the location of the shape, but not its shape or size. Let's do our core concept check on congruency transformation. Number 1, please complete the following sentence. Two geometric figures are blank if and only if there is a rigid motion that moves one figure on to the other. The answer would be congruent. Two figures are congruent if and only if there is a rigid motion that moves one figure onto the other. If you are wondering what the word congruent is, it is a adjective, okay, that describes figures that are the same in shape and size. That is the definition of what congruent is. Number 2, what does the three transformation, translation, reflection, and rotation have in common? There are multiple answers to this. One answer I can give is that they create a congruent figure at different locations, like the core concept here. Good. Now let's look at an example. This example asks you to identify the congruent geometric figures. You're going to answer the following questions about the figure. Number 1, what shape is congruent to square A, B, C, D? I would say square Q, P, and R are congruent. The reason why? Question 2. Explain why square A, B, C, D is equal to square Q, P, and R. The reason why is square Q, P, and R is a translation of square A, B, C, D. That means they slide down here. The fact that you can slide this square on top of this square, you can say that they are congruent. Number 3, what shape is congruent to triangle KLM? We can see that triangle KLM is right here. And you can see that this shape of EFG is congruent. How they are congruent? By looking at a reflection. So you can say that this was reflected, was a reflection across the x-axis. Good? So the question now is that if LM right here is the value of 4 inches, which is right here only, what is this value of FG? We would say that line segment LM and line segment FG are congruent because, again, their shapes were congruent. Therefore, line segment LM is equal to 4 inches. And also, we can say that line FG is also equal to 4 inches. Next, what transformation proves that triangle STU, which is right here, STU is congruent to triangle HIJ? How are these two triangles congruent? Well, there are two things you can say. You can either say it was reflected across this line here. Okay, that's what I said here. Reflection over y. This line is y equals to x. It can either reflect that, or you can say that it was rotated by 180 degrees. Let me show you. It rotates 90 to go this way. Then it does it one more time. It goes 90 this way. In total, that was a rotation of 180 degrees. Now, the question is this. If the angle measurement of angle J here was 60 degrees, what is the angle measurement of U? You can say that angle U and angle J are congruent because their figures are congruent. So angle U will also be 60 degrees. Like before, we said it in our core concept. If you perform a congruent transformation with either a rotation, a reflection, or a translation, the length and the angles are the same in both objects. That is the reason why 6 and number 4 are correct. Our last problem is a higher order thinking problem in this scenario. A beam of light from this lamp is reflected off a mirror laying flat on point B. This is where the mirror is. Please note that angle B is in the middle of line CA. If it's in the middle, you would understand that these are going to be equal distance. Okay, it cuts it right in the middle. Here are the 5 questions. 1, you are going to explain whether or not angle CBD is congruent to angle DBE. Are these two congruent? You would say they're not congruent. The reason why they're not congruent is because you cannot form a translation so that they're on top of each other. You cannot slide it, you cannot rotate it, you cannot reflect it. That's why they are not congruent. So, what is congruent to the angle of CBD? We would say that angle ABE is congruent, and the reason why, because you can reflect it or you can rotate it, but I said I can reflect it across the point B. So if CBD is 30 degrees, the question is, what is the value of angle DBE? Please understand that angle DBE is right here. This is the question mark. All right. So notice that triangle CBD was 30 degrees, and we know from question 2 that triangle ABE is also 30 degrees. Okay, so we need to know what this one's left. Understand that a line is 180 degrees. Okay, so we know 30 and 30 make 60. So what is left? This has to be 120. That is what's left. Okay, next, let's take a look at number 4. What shape is congruent to line segment AB? Well, we would say that CB is congruent to line AB. The reason why is by what? You can either say by reflection on point B, or you can actually say translation. Okay? Or you can actually say rotation, right? All of them work here. You can, because you can rotate it 180 degrees as well. Okay? So all 3 transformation works to prove that they're congruent. So the question here is, name what geometric shape is a result after you combine line segment AB with line segment CB. They would make the line CA. Please understand that this is a line. This was a line segment. A line goes on forever. Notice that once you add these 2 line segments, you have the arrows here. That proves that it goes on forever. Okay, so there you go. That is your video lecture on congruent transformations.